Right, so 10.9 is called the convergence of Taylor series. Which again, as I am going to define, sort of talk about what the convergence would be, what the error would be, and we'll talk more about that. But I think most of the error problems shows up in the next section. But what we are going to see on here is something like this. So it's still more of what we're doing. So example. So find the Maclaurin series for the following functions. So number one, f of x is equal to, how about e to the 2x? So now you don't have to go through everything we did in the previous section, right? So you don't have to go through, oh, I have to find the first derivative, the second derivative, the third derivative, and so on and so forth. You can certainly do that, okay? But since the direction says Maclaurin, then the center is 0, so you can make use of the result of what we already did a while ago. So recall that e to the x is simply n equals 0 to infinity, x to the n power over n factorial. Well, all I did here is that the x gets replaced with 2x. So then that means this is simply the power series, n equals 0 to infinity, of 2x to the n power over n factorial. Right, so I just simply replaced x with 2x. Well, then now just write it out nicely. So this would be, splitting it up individually, you're going to get 2 to the n, x to the n, over n factorial. And there is your power series. Questions on that? Any questions on it? Okay, so I want you to try this one. Okay, so number 2. So how about f of x equals e to the negative x power? Right, again, this should be quick, right? So because all you're doing is replacing x with negative x. So your power series is going to be negative x to the n power over n factorial. Well, just split the negative from the x. And so what you have is n equals 0 to infinity, negative 1 to the n, x to the n over n factorial. And there is your power series. Questions on that? Any questions on it? Okay, so I want to try another one. Okay, so example number 3. So f of x is equal to, what do I want to use here? Let's do this one. So how about x times sine x? Okay. So this is more of a substitution, right? So you're replacing the x in your power series. This is a product, right? So it's an x times a sine x. So recall, sine x is the power series from 0 to infinity of sine is the odd one. So it would be negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And so now all I'm going to do is multiply that by x. So this is equal to x times the power series questions. Okay. All right, now let's briefly talk about what exactly is happening here, right? So remember, this is a polynomial, right? So that part right here is a polynomial. So this one has multiple terms. And if you sort of flip back to your notes a while ago, right? So sine x is this polynomial, right? It's right here. Okay. Yes, the -1 should still be in there. Did I remove it? Oops. Yep, I did. I took it out. So yes, it still has the n power. Okay. So remember, this is just a polynomial with the odd powers on them. Okay. And so when you have a term times a polynomial, the term just gets distributed. So you just end up multiplying x to each term. Well, if you multiply x to each term, all you're doing is increasing each term by a 1 power, because this is x to the 1. So the result would be from n equals 0 to infinity of -1 to the n. And I'm just going to end up adding 1 to this one. So it's x to the 2n plus 2 power all over 2n plus 1 factorial. And there is your power series. Any questions on that? So yes, the -1 still has the n power, right? Okay. So I want you to try this next one. Okay. So number 4. So f of x is equal to an x squared over 1 plus x. Okay. So x squared over 1 plus x is actually x squared times 1 over 1 plus x. So do exactly the same thing, but using this as your power series. So go ahead and try this out. Okay. All right, so then now it's just x squared times the power series for 1 over 1 plus x. And if you recall, the power series for 1 over 1 plus x is your -1 to the n, okay, x to the n over n. Oh, sorry, it's just x to the n. My bad. And so now just multiply by x squared. So the x squared gets multiplied to x to the n. So the power series is n equals 0